Welcome back. My students will be happy to know this is the last, or getting close to the last of the 9-minute lectures that are up on YouTube. Those of you who take this course later, they'll all be on disc, of course. But we're really winding down to the end of the class. There's, I don't know, maybe just a couple more sections of lecture, all on the same topic, which are vectors and dot product. The definition of dot product and what's going on with vectors belong to a couple lectures before this. What I really wanted to concentrate on was the notion of the projection of u on v and the component of u on v. As I said last time, I went into some detail. This is a scalar, and it's just the magnitude of the direction that the vector u is lying in the direction of v. So let me give you a couple drawings here. Suppose this is v, and this is u. Suppose that the sun is up here, shining down. What are they talking about? The projection. First off, what's the projection of u on v? It's the projection is what lies in the direction of v. This is not a scalar. This is a vector. If you break this down, this is going to be this vector right here. And this is the norm of u, the length of u, times cosine theta. This is the magnitude, or the component. And because we don't know if we're in the I or the J direction, these are just in relationship to each other, these vectors. Then we multiply this by the unit vector. I hope it is the case that all of you can break down what these symbols mean and see that this is the case. So this is the projection right here of u on v. It's the part of u that lies in the v direction, right? And that's this whole thing. It's a vector. The component is just the number, the numerical number in front of that, okay? I'm going to do a couple problems with these so you feel comfortable with them. I remember when I was first doing this a billion years ago, when the dinosaurs roamed the earth, this was driving me nuts. Number one, trying to remember even the definition, but really trying to understand what they were. And this notion of sun and projection, I think, is really helpful. A problem just like you'll see on your homework. Suppose that u is equal to 4 and minus 3, and v is equal to 2 and 1. And we want to find the projection of u on v, and I suppose I should always be putting these little arrows. If I forget to put the little arrows, it's just because I forgot. And the reason why you don't use arrows in the book is because they have that nice thick type that I really can't reproduce on the board. Well, so even if you don't remember what these are, it is a formula. So what is the formula? It says it's u dot v. What is u dot v? It's going to be this times this, 4 times 2, plus this times this, minus 3 times 1. This bit of it is 8 minus 3, this is 5, divided by the norm of v squared. Well, the norm of v is going to be 2 squared plus 1 squared, square root. This is the square root of 5. The norm squared is going to be this squared. This is just 5. Okay, so far so good. Then we have to multiply it by v, right? This is the scalar, this is a vector, but I'm just going to write this right there. V, this is 1. It turns out that the projection of u on v in this particular case is simply v, which, okay, so somebody may insist you write it like this. But that's it. If you really, hopefully you get a good feel for what this is, but if you don't, just follow a formula. And you should definitely know, if somebody says which one's a vector and which one's a scalar, and this one has a vector in it, this one doesn't. We took the norm, it's a number now. So that's it for that one. Okay. Next, I'm going to compute a component. And what, did I use the same? No, I think I just made some stuff up. So we're getting close to the end of the show now, and the t-shirt of semi-disgust is getting much closer to its relative, the t-shirt of disgust. Hello there! We're going to do a problem that I just made up. It's an obvious one. and hopefully you'll find it to be quite easy. We want to find the projection of u and u on v. So, or I'm sorry, the component. Ooh, this I don't like. This marker is no good. Okay, this has to go away. 2 points. So suppose that u is equal to 1, 2, and v is equal to 3 and 4. And so this should look pretty obviously that I just made these up with some pretty easy numbers. What's the component? So what's the component of u and v? It's basically this. It's the norm of u times cosine. And once again, let me try and do this again and make this clear. Here is v. Here is u. Here is the projection down on v. So here is the actual vector. That's the vector component of u along v. This is some number times the unit vector v, right? What is the number? The number is the absolute value, or the norm of u times cosine theta. So the norm of u is going to be this squared plus this squared square root. This is 1 squared plus 2 squared square root. This is the square root of 5. What is cosine theta? Well, we know that u dot v is equal to the norm of u times the norm of v cosine theta. So once again, assuming that u and v are not the zero vector, because then the norms would be 0, we'll be dividing by 0. We know that cosine of theta is equal to u dot v divided by the norm of u, the norm of v. Okay, so we already have the norm of u. We might as well figure out what the norm of v is. The norm of v is going to be this squared plus this squared. Well, it turns out that 3 squared plus 4 squared square root is the square root of 25. This is just 5. What is u dot v? Well, u dot v is going to be this times this, 1 times 3, plus this times this, 2 times 4. And on a good day, this is 11. So let's put all this together. We need, this number is the norm of u times cosine theta. That's going to be the square root of 5, times, we figured cosine theta was u dot v, 11, divided by u, or the norm of u, norm of v. So this is 5 square root times 5. This is 11 fifths. And remember, does this seem right? It should be, because it's a number. Okay, so we did that. We only have a minute left on this. So I did that a little with more work than you really needed to, because remember, we have this definition. The definition says it's u dot v, which is, where'd it go, 11, divided by the norm of v, which is 5. This is, of course, the same answer. If you just go with the formula, that's fine. The reason that I work through it so much is so you really get an idea of what this is. We will be right back.